What about those shadows? When light shines on an object, some of the rays may be stopped while others pass on in a straight line path. A thin beam of light is often called a ray. Any beam of light, no matter how wide, can be thought of as made of bundles of rays. A shadow is formed where the light rays cannot reach. So if something is blocking a ray's path, you will start to see a shadow. Sharp shadows are produced by a small light source nearby or by a large source farther away. However, most shadows are somewhat blurry, with a dark part on the inside and a lighter part on the edges. A total shadow is called an umbra. In a total solar eclipse, if you are in the path of the shadow of the moon, then you see the total solar eclipse, totality of the solar eclipse. If you're just outside of the exact shadow of the moon, you are in the penumbra. Penumbra is a partial shadow. A penumbra appears where some of the light is blocked out, but other light is able to fill it in. A large light source produces a softer shadow on the left than a smaller light source. The smaller light source has a more distinct shadow rather than the fuzziness or the blurriness. An object held close to a wall casts a sharp shadow, and as the object is moved farther away, penumbras are formed to cut down on the umbra, giving this blurry look. When really far away, the penumbras mix together into just one big blur. A penumbra occurs when the moon passes between Earth and the sun during a solar eclipse. The moon's shadow barely reaches Earth. If you stand in the umbra shadow, you experience brief darkness during the day. If you stand in the penumbra, you experience a partial eclipse. The sunlight is dimmed and the sun appears as a crescent. Find out when the next total solar eclipse is happening and do what you can to get in that umbra, get in the full shadow. It's an experience you'll never forget. Earth, like most objects in sunlight, casts a shadow. The shadow extends into space, and sometimes the moon passes into it. When this happens, we get the lunar eclipse. A lunar eclipse can be seen by all observers in the nighttime half of Earth, so the side that would see the moon. Shadows also occur when light is bent in passing through a transparent material like water. Light travels at slightly different speeds in warm and cold water. The change in speed causes the light to bend, just as layers of warm and cool air in the night sky bend starlight and cause twinkling. This, in astronomy, is called seeing. When you go outside and you see the stars and it looks like they're twinkling or it looks like they're getting brighter and dimmer really fast, that's what's happening. The change in speed that the light is traveling through the atmosphere. Some light gets deflected a bit and leaves darker places on the wall. The shapes of shadows depend on how the light is bent. A heater at the tip of this submerged J-tube produces convection currents in the water. They are revealed by shadows cast by light that is deflected differently by the water of different temperatures. See the darker shadows, the more distinct shadows versus the blurry shadows. Think about this. Why are lunar eclipses more commonly seen than solar eclipses? There are usually 2 of each year. However, the shadow of the moon on Earth is very small compared with the shadow of Earth on the moon. Only a relatively few people are in the shadow of the moon, the solar eclipse, while everybody who views the nighttime sky can see the shadow of Earth on the moon, the lunar eclipse. So now you should be able to comfortably answer this question. What causes the formation of